Ever feel like you're just adrift in a sea of information like you're supposed to know about cybersecurity, but it all feels kind of overwhelming?
Uh-huh. Yeah, I know that feeling.
Yeah.
It's easy to get lost in the jargon, that's for sure. But the truth is, cybersecurity affects all of us, no matter how tech-savvy we are or aren't.
Exactly. So today, we're diving headfirst into the hows and whys of staying safe online.
We'll unpack everything from the basic principles of cybersecurity, like the foundation,
Right, like what are we even trying to protect here?
to the actual tools and tech that can keep our data from, well, ending up on a billboard somewhere.
Because nobody wants that.
Definitely not.
You mentioned something about the value of data and information in our prep notes. What makes that so important in the world of cybersecurity?
Well, think about it this way. Every time you shop online, you're handing over your credit card details. Every doctor's appointment generates medical records, every social media post, every email. It's all data.
Okay, so data is everywhere, that's for sure.
And that data is valuable,
Right.
not just to us, but also the people who might misuse it. Cyber criminals, for example, they're always looking for ways to steal identities, financial info, you name it. And then there are the nation states. Sometimes they're after economic or political leverage, and they're not afraid to use cyber attacks to get it.
So we're talking about some pretty high stakes here.
That's why understanding how to protect that data, that's where cybersecurity comes in.
So it's bigger than just remembering to change your password every few months.
Way bigger. Remember that big data breach a while back? The one with that credit bureau? Millions of people's information just
Yeah.
out there. And it's not like you can just change your social security number, right? It can take years to sort out the fallout from something like that.
Okay, I'm starting to see why this is so important. So where do we even begin to build up our defenses in this digital world?
Well, one of the most fundamental concepts in cybersecurity is something called the CIA Triad: confidentiality, integrity, and availability. It's like the bedrock of a secure system.
The CIA Triad sounds kind of intense.
It's not as intimidating as it sounds. Think of it like the legs of a stool. You need all three for it to stand strong.
Okay, so let's break it down then. Confidentiality, that seems pretty straightforward. Keep things private, right?
Yeah, but it's more than just hiding information. Confidentiality is about making sure that only the people who are authorized to see the data, they're the only ones who can access it. So like multi-factor authentication, where you need your password plus, say, a code from your phone, or maybe even a fingerprint scan. Those are all ways to bolster confidentiality.
So it's about proving you are who you say you are.
Exactly. Not just keeping things locked up, but making sure the only people with the key can get in.
Okay, that makes sense. What about integrity? What does that mean in this context?
So integrity basically guarantees that the data hasn't been messed with,
Messed with.
right? Like altered or corrupted.
Hmm.
Think about it. A hacker could change financial records to reroute funds or even tamper with medical prescriptions. It's scary stuff.
That's terrifying.
To prevent that, we have things like hashing. It's basically a digital fingerprint for data. Any tiny change, even just one character in a document, will completely alter its hash. So you can quickly tell if something has been tampered with.
Oh, so if the hash doesn't match, you know something's up.
Exactly.
Yeah.
Like a silent alarm going off.
That's really clever. And that brings us to the last piece of our CIA Triad puzzle: availability.
And availability just means making sure that the data and the systems that store and process it, they're accessible whenever authorized users need them.
So if I need to access my bank account, it's actually available, not down for maintenance or something.
Exactly. But it's more crucial in some areas than others. Imagine a hospital, right? If their systems crash during a critical moment.
That could be a matter of life and death.
Ex
So how do we make sure those crucial systems stay up and running, even when things go wrong?
Redundancy. That's the key. Basically, you need backup plans.
Okay, so like having a spare tire in your car.
Exactly. Or a backup generator if the power goes out. In the IT world, this could be redundant servers or networks. If one system crashes, there's another one ready to pick up the slack.
So with availability, it's all about hoping for the best, but preparing for the worst. So we've talked about protecting data, but how does it actually move around these networks? I have to admit, I used to think it was like sending one giant file through the internet tubes.
Uh-huh. The internet tubes. That's a classic. But yeah, it's a bit more complicated than that. In reality, data travels in these little packages called packets.
Packets, like what do you mean, like little envelopes?
Sort of. Imagine you're trying to send a whole encyclopedia through the mail, right? Instead of sending it as one massive book, which could get lost or damaged, you break it down into smaller chapters, each with its own packaging and address label. Packets are basically those individual chapters of data.
Okay, so it's like chopping up the information into bite-sized pieces.
Exactly. Each packet carries a chunk of the data, but it also includes important header information, things like the sender's address, the destination address, error checking codes, even packet numbers so they can be reassembled in the correct order at the other end.
So it's like a digital jigsaw puzzle then.
Exactly. And the beauty of this system, called packet switching, is that even if a few packets get lost or delayed in transit, the receiving computer can request them to be resent. It makes the whole process super resilient, much more so than relying on one big file that could get corrupted.
It's like having built-in redundancy from the ground up. That's pretty cool. Now, I've always wondered about those addresses. Computers don't actually use those www dot whatever addresses to find each other, do they?
You're right, those are domain names.
Yeah.
They're mostly for us humans because we're not so good with remembering long strings of numbers.
Thank goodness for that.
Computers use numerical addresses called IP addresses to communicate, kind of like a phone book. We use names to find who we want to call, but the actual call goes through using phone numbers.
So there's a whole translation process happening behind the scenes then.
Exactly. And that's where the domain name system comes in, or DNS as it's usually called. You can think of it like a giant global directory that links those easy-to-remember domain names to their corresponding IP addresses.
So every time I type in a website name, my computer's basically asking a DNS server, hey, what's the IP address for this?
Pretty much. The DNS server looks it up in its directory and sends back the IP address, allowing your computer to connect to the right server. And it all happens in milliseconds.
Wow, it's incredible how smoothly it all works. You never even realize it's happening.
It's a testament to how well designed the system is. And speaking of design, there are actually two main versions of IP addresses in use today, IPv4 and IPv6.
Wait, two versions? Why do we need two different types of IP addresses?
Well, it all comes down to the address space, which is basically how many unique addresses are possible. The older system, IPv4, uses 32-bit addresses, which seemed like a lot back in the day.
Back when computers were the size of rooms, right?
Right. But nowadays, we've got smartphones, smart refrigerators, even smart toasters, all needing their own unique IP addresses.
So we basically ran out of numbers.
Essentially, we were running out of IPv4 addresses. That's why IPv6 was created.
So IPv6 is like the Internet expansion pack then.
Exactly. IPv6 uses a whopping 128 bits for its addresses, which provides exponentially more possibilities. We're talking about enough addresses for every grain of sand on Earth and then some. It's future-proofing the Internet, essentially.
That's a relief. I wouldn't want to imagine a world with internet address rationing or something. Okay, so we've got these IP addresses, but then you also mentioned something called MC addresses earlier. Are those related?
They are, but they serve a slightly different purpose. Think of it this way. Your IP address is like your street address. You can change if you move to a new house or city. Your MC address, on the other hand, is like your social security number. It's a unique identifier that's assigned to your device at the factory and stays with it no matter what network you're on.
So it's like a device's permanent ID card?
Exactly. MC addresses are primarily used for communication within the same network, like if you're sending a file directly to your printer, for instance.
So we've got packets traveling around, addresses making sure they get delivered correctly, and DNS acting as a giant directory. It's amazing how it all comes together.
It's a beautifully intricate system, really. And speaking of systems, let's shift gears a bit and talk about the actual hardware that makes all of this possible.
Okay, so we're going beyond the abstract and getting into the physical devices now. Like, what can I actually see and touch in my house?
Exactly. Let's talk about modems, routers, switches, access points, all those boxes and gizmos that most people have in their homes but don't really think about. They're the unsung heroes of our connected world.
Modems. I haven't heard that word in ages. Those have been around since the dial-up days, right?
They have, and they're still just as crucial today, even if they look a little different. Modems are essentially the translators between your home network, which uses digital signals, and the internet service provider's network, which often uses analog signals.
So they're like the interpreters of the internet?
That's a great way to put it. They modulate or change digital data into those analog signals for transmission over telephone lines, cable lines, or fiber optic cables. And then on the receiving end, they demodulate those analog signals back into digital data that your computer can understand.
It's like having a universal adapter for data. Amazing how something so small can bridge such a fundamental gap in communication. It really makes you appreciate the complexity of it all. So we've got modems handling the translation between our homes and the outside world, But where do routers fit in?
If you think of modems as the translators, then routers are like the traffic directors of the internet. They manage the flow of data between networks, ensuring those packets we talked about earlier get delivered to the right devices.
So, kind of like an air traffic controller, but for data.
Exactly. Think about all the devices you probably have connected to your home Wi-Fi. Phones, laptops, maybe a smart TV or two. The router acts as that central hub, directing traffic to the correct device, and even managing connections between those devices.
So it's like the central nervous system of our home network, making sure everything can talk to each other smoothly.
A great analogy. And routers are also super important for security. They act as a firewall, filtering both incoming and outgoing traffic and blocking anything suspicious.
So they're like security checkpoints, making sure nothing shady gets through.
Precisely. And then we have switches. While routers connect different networks, switches are all about connections within the same network.
So if I'm sending, say, a document to my printer and it's on the same network as my computer, the switch handles that transfer directly?
Exactly. They're all about speed and efficiency. Switches examine the destination MAC address of each packet and then forward it only to the intended recipient, not every single device.
Oh, that makes sense. So it's like sending a letter directly to someone's desk instead of just yelling it out in a crowded room and hoping it reaches the right person.
A perfect way to put it. It reduces unnecessary traffic and keeps everything running smoothly. And finally, we have access points, the unsung heroes of our wireless lives.
Ah, yes. Access points. They're what give us the magic of Wi-Fi, right?
Exactly. They take that wired internet connection from your modem or router and broadcast it wirelessly, creating that invisible network we all rely on.
So they're like little radio towers beaming data through the airwaves.
Another great analogy. And just like radio towers, their placement is important. You want good coverage, but you also want to consider security implications.
It's amazing how all these different devices work together, like a finely tuned orchestra. Modems, routers, switches, access points. Who knew there was so much going on behind the scenes to keep us all connected?
It's a true testament to human ingenuity, that's for sure. And as we rely more and more on these networks for everything from communication to banking to healthcare, really understanding how they work and how to keep them secure becomes even more vital.
Absolutely. And on that note, I want to thank you so much for guiding us through this fascinating deep dive into cybersecurity. It's been eye-opening.
My pleasure. Always happy to share my passion for all things cybersecurity.
And to all our listeners, thank you for joining us today. We hope you learned something new and feel empowered to navigate the digital world a little bit more safely and confidently. Until next time, stay curious.